Hello, ladies and gentlemen of Algebra 2, looking at 9.2, talking about adding and subtracting rational exponents. And it might be to your advantage to think about adding and subtracting fractions. So, when you look at this, it's a good idea to think about, if I was going to add 4/5 and 6/7, I would really hope that none of you would try telling me that it is 10/12, because that is not right. I'm really hoping that some of you guys would think, well, I need to find something in common here. I need to manipulate the top numbers, and then I can add them together. That is what we were doing, except now we are doing it with considered a rational thing here. So, in order to make a picture that is in focus, the distance between the camera lens and the film must be controlled so that it satisfies a particular relationship. The distance is given below. So that's kind of what I'm looking at. So if I want to take 5/6 minus 1/4 to figure out 1 over q, that's what I need to do. So what I need to do is figure out a common denominator between 6 and 4. So that would be 12. I'm hoping some of you jumped right through that. So to get from 6 to 12, I multiply by 2. So I must multiply this top by 2. So if I would go from 4 to 12, I'm going to multiply by 3. So I need to multiply this by 3 and get 3. So this is going to be 7/12. And that would be my answer for 1 over q. So now I need to do the least common multiple of polynomials. So it's going to be in factored form and contains each factor the greatest number of times the factor appears. So the LCM of 6 and 4, we figured out, is going to be 12. So if I look at the LCM of p minus 3 and p squared plus 6p minus 27, I'm hoping that if you factored that, you would get p minus 3 and p plus 9. So my LCM would then be p minus 3 times p plus 9. So each factor, the greatest number of times the factor appears. So I want you to factor all the polynomials, multiply each polynomial by the factor it's missing, then use each factor the greatest number of times it appears. So if I look here, I'm looking at number 2 now, and I'm looking at 12a squared b fourth, 27ac to the third, and 18 a to the fifth, b squared, and c. So if I think about this, I think about the numbers, 12a squared, b to the fourth, 27a, c to the third, 18 a to the fifth, b squared, c. So 12, 27, 18. Let's see, 12, 27, and 18. So if I look at this, if I go 3, 2, 2, 27 will be 3, 3, 3. 18 will be 3, 3, 2. So let's see. I've got 3 times. And I've got 2 twice. That is the greatest number of times that those show up. 3 shows up 3 times here. 2 shows up twice here. So I'm going to multiply those. So that would be 27 times 4. And 27 times 4 is going to be 108. Now I look at, for A, what is the most number of times A shows up? That would be A to the fifth. B, B to the fourth, B squared, so that would be B to the fourth. And C only shows up there, and it's C to the third. So there would be my least common multiple. If I multiplied all those things together, that's what I would get. All right, so again, follow. Factor, multiply each polynomial by the factor is missing. Use each factor the greatest number of times it appears. That's kind of what I'm looking at, this part 3 here. Use each factor the greatest number of times it appears. All right, now 3 got blocked. I'm trying to move this over a little bit. It's not wanting to let me do it. There we go. So 3, your 3 should look something like this. It should go 6m to the third and to the fifth, Then you're going to have 42 mnp squared. Then you're going to have 36 m to the third n to the fourth p. So 6, 42, 36. So if I break that down, that'll be 3 times 2. This would be 7 times 3 times 2. This would be 3 times 2 times 3 times 2. So 3 shows up twice, 2 shows up twice, so that'll be 3 squared times 2 squared times 7. So 9 times 4 times 7, so that'd be 28 times 9. I'm going to cheat and use a calculator. So I'm going to get 252. Now, where's the most amount of times m shows up? Well, m to the third, n to the fifth, n to the fourth, n to the fifth, p squared, and p, so it'd be p squared. There is my least common multiple. I'm looking for the smallest thing that combines everything as many times as it shows up. That's kind of a different way to say it. So here, my first instinct would be I'm no longer dealing with one-term things. Now I've got multiple-term things. So I'm going to take this first one, and I notice right away that I can factor out p. Then I believe I can factor that into p plus 3 and p plus 2. Now on the other side, nothing can be factored out right away, but that will be p plus 3 times p plus 3. So now remember, for least common multiple, I am looking at what is the most amount of things, most amount of times something shows up. Well, p shows up there. P plus 3 shows up twice. And p plus 2 shows up. That would be my least common multiple. P shows up once. P plus 3 shows up twice. P plus 2 shows up once. That is going to be my least common multiple. So factor everything, okay? Figure out how many times each shows up and include it. So here, for this one, I'm going to factor out k. I'll be left with 2k squared minus 5k minus 12. Factor that. So that would be negative 8, positive 3. So factor, 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 factor. So 2k, k minus 4, 3, k minus 4. So I'm going to have k, 2k plus 3, k minus 4. On the right side, I'm going to have this. Change colors here. I will have k. I'll be left with k squared minus 8k plus 16. I'll have k minus 4, k minus 4. When I factor that, nice and easy. So when I put this together to actually figure out what my common multiple, my least common multiple, I'm going to have k, because k shows up once. I will have k minus 4 twice, and I will have 2k plus 3. That would be my least common multiple, right there. Notice, factoring everything first, completely, and then going from there. So now, adding and subtracting, just like fractions, you got to have common denominators. So you got to have that same thing in the top and bottom in order to figure this out. So if I'm looking to simplify this, the first thing I need to do is find my least common denominator. So I will look at that over here. So 15y squared, 18xy. Well, that's 3 times 5. That's 3 times 3 times 2. All right, so 3 shows up twice, and a 2 and a 5. So that'll be 90. And then x, y squared. Sorry, not y cubed, y squared. So that becomes my new least common denominator, or least common multiple. So that becomes my common denominator. So now I need to figure out how do I manipulate the top to match the bottom. So this becomes, so 90xy squared would be 3 times 3 times 2 times 5 times x times y times y. Well, I have 7x, but what do I not have already on that underneath? Well, I need an x, and I'm going to need a 3 and a 5. I'm sorry, a 3 and a 2. So I've got a 3 and a 5 and 2 y's. So I need another 3 and a 2. So I'm going to multiply 7 times 6, and then multiply it by x. Then on the other side, I've got an x, okay, I've got an x, I've got 1 y, I've got 3, 3, 2. So I need 5 and a y. So I already have the y from previously in the problem. So I need to multiply by 5y. So now this becomes 42x squared over 90xy squared plus 5y squared over 90xy squared. Now I can put them together. 42x squared plus 5y squared all over 90xy squared. But the important thing, two big pieces here. One, I've got to find my least common denominator. Two, I need to figure out what do I need to multiply on the top that's not already there. So if I look here, first thing I should do is figure out my least common multiple, to figure out my least common denominator. So this is going to be 3 times b. This one will be 7 times a times b times b. So my least common multiple will then be 3 times 7 times a times b times b. B shows up twice, a once. There's a 7 and 2 3's. So 3, 3, and 7 would multiply to 9 times 7 would be 63ab squared. So this becomes my new common denominator, 63ab squared minus 63ab squared. So now, start off with what's already on top, and then what did I have to add to the bottom to get 63ab squared? What do I have to multiply to the bottom? Well, already on the bottom I had 9b. Already on the bottom I had that. So that means I have the 3's, I've got one of the b's. So that means I need to put on top a 7, a, and a b. For the other one, I've already got a 7ab squared. So I've got the 7, I've got the a, and I've got the b squared. So what I need to add on top is the 2 3's. So this is coming from what I figured out to be my least common multiple. So now when I put this together, that will be 56a squared b minus 9 over 63ab squared. There is my fully simplified answer. So now, between 8mn squared, 8 would be 2 times 2 times 2 times m times m times n. Mn squared would be m times n. So my least common multiple would be 2 times 2 times 2 times m times n times n, otherwise known as 8m squared n squared. So my least common multiple, which would become my least common denominator, would be 8m squared n squared plus 8m squared n squared. So 1, now what do I need to add to this one? Well, all I need to add is one more n. Over here I've got the two m's, I've got the two n's and an m. I need to add 8m. So my answer becomes n plus 8m over 8m squared n squared. There's my answer. So here, 3xy and 5y. So this one becomes 3 times x times y. This one becomes 5 times y. So common would be 3, 5, x, and 1y. So that would be 15xy. So my new denominator is 15xy. So now, how do I change my top? Well, I'm going to have the 2 already. Now I've got 3xy, so what do I need to add? Well, just a 5. For the second one, for the 5y, I've got a 5 and a y. I got a 5 and a y. Okay, I've already got the 3x there that's already in the top. So now I need to add another 3x. So when I put this together, it becomes 10 over 15xy minus 9x squared over 15xy. Then I can put it all together, 10 minus 9x squared over 15xy. There's my answer. So factoring, this is where the fun begins. Factoring is a necessary evil, so this becomes 4w minus 4. Then over here becomes 2 and w minus 4. So now to figure out my common denominator, all right, well 4 can be 2 times 2, so I need 2 times 2 times w minus 4. There's my least common multiple, so that'd be 4 times w minus 4. So now, rewrite that, which on this first one doesn't mean I change anything, so it's already 4w minus 4. That one doesn't change. But for the second one, instead of the 2, I need to add another 2, or I need to multiply by another 2. So that's subtraction, so it becomes 4w minus 4. Then on the top, I'm going to multiply by another 2. So on the bottom, I get 4w minus 4. On the top, I get w plus 12 minus 2w minus 8. So now I can simplify this. So now I get minus w plus 4 over 4w minus 4. And what I can actually do to be clever is I can pull out a negative 1. And then I've got the same thing on top and bottom. So my final answer becomes a negative 1 over 4 because those cancel out. Good problem. Good problem. But the important thing is I take all the factors once I factor them and go from there. So for 11, take a look. X squared minus 4 becomes x plus 2, x minus 2. Over here I've already got an x plus 2, so what I need to, my least common multiple here is going to be x plus 2, x minus 2. So, first one doesn't change. It's just written a little bit differently. Over here, x plus 2, x minus 2. I have an x on top. But what I need to put on over here is another x minus 2. So when I put this together, and I actually distribute this, I get 1 plus x squared minus 2x all over x plus 2, x minus 2. And what's interesting is that rewrite that top one. Factors of 1 that add up to negative 2, this becomes x minus 1 and x minus 1. So my fully factored answer would literally be x minus 1 times x minus 1 over x plus 2, x minus 2. Take a look at that. There was a lot to that problem. Good for you. All right, this is where the fun begins because this one's not easy. So for here, for the first one, for 12, I'm going to factor this thing. So I need multiplies to 15, but adds up to 8. Well, my first step is going to be rewrite that like so. So I will get 3x, x plus 1, plus 5, x plus 1. So 3x plus 5, x plus 1. Over here, if I pull out 4, I'm left with 3x plus 5. So now my full-on LCM would be 4, 3x plus 5, and x plus 1. So now, this is rewritten like this. Okay, so all I need to add to that first one is a 4. Let's go with that. So this becomes 4x minus 1 over 4 3x plus 5 x plus 1 minus, then over here, same denominator, but look at what needs to be added to the top. So I've got x minus 1, and then I need to add an x plus 1 to the top. Okay, so I need to add, once I factor this, I need to rewrite using my common denominator. Now, I've got a common denominator. Put this all in one problem, and I'm going to actually kill two birds with one stone and go like so, all over 4 3x plus 5 x plus 1. Then if I combine this whole thing, let's do this. I'll put it right here. So that becomes negative x squared minus 4x minus 3 all over that. That would be my answer right there. Good problem. Good problem right there. So 13, this would just be a minus 5, a plus 4. So that means that the first one, nothing would really change. I would just factor the bottom. On the second one, a plus 4, I've got to put on an a minus 5. First one, top stays the same. Second one, stop. I need to put an a minus 5 up there. So then distribute that. A plus 2a minus 10 all over a minus 5, a plus 4. So that'll be 3a minus 10 over a minus 5, a plus 4. I know it sounds weird. You're actually simplifying the top but while leaving the bottom factored. But that's kind of what you want. You got to put it together and then see if you can pull it back apart and do anything with it. And in this case, no, we can't. So slope, ooh, interesting. Find the slope that passes through that and that. So that would be 3 over p minus 1/2 over 1/3 minus 2 over p. So this will be a nice challenge problem here. So the first thing I'm going to do is put this all in one together. So that would be p over 3p minus 6 over 3p. So a common denominator here is going to be 3p. Common denominator up top is going to be 2p. So that would make that 6. 2p, that would make that p. So then my first kind of maneuvering here would be this. I will have 6 minus p over 2p over p minus 6 over 3p. So remember how you get rid of fractions within fractions. You multiply by the reciprocal. That cancels, that cancels, that cancels, that cancels. But you do it to the top as well. So you have 3p over p minus 6. And then you're going to multiply all these things. So you'd have 3p times 6 minus p over 2p times p minus 6. So what I would end up with then is this. 18p minus 3p squared over 2p squared minus 12. So let's see if I can maneuver some things around here. So if I pull factor out, so this top one, if I factor out, I'm coming over here now, negative 3p, I would be left with p minus 6. On the bottom, if I factor out 2p, I'd be left with p minus 6. So now all of a sudden, all sorts of things can cancel out. That can cancel, that can cancel, p. So after all that noise, I get negative 3/2 for my slope. All right, good questions. Play around with this, take your time. This last problem was pretty tough, so if you need to rewatch it again, do so. But all I did, a lot of algebraic work, just multiplying things and factoring things.